It's useful when thinking about radio waves to think about light waves. We talk about light traveling in rays. Radio waves do the same. That's called radio propagation. And just like light passing through a prism and separate into its various colors, the properties of radio are going to depend critically on the wavelength. So when white light goes into a prism and is separated into red, orange, yellow, green, blue, and violet, radio waves are going to propagate differently depending on their wavelength too, which is much bigger than light wavelengths. We'll consider the propagation, that is radio rays, traveling in order to communicate with users who are in different parts of the world. Imagine, for example, that we're using, in radio terms, part of the VHF spectrum. Radio in the VHF band travels in a straight line. The rays travel using line of sight. Now imagine the person that you want to talk to is on the other side of the world. If the radio wave uses line of sight propagation, it travels in a straight line. It's not going to go around the curve of the Earth. So the solution for contacting somebody who's over the curved horizon is to put a satellite up, and the satellite will receive the signal from the radio caller and then transmit it in another straight line of sight, to the person receiving it at the other end. UHF, which for example would be 400 megahertz, operates in exactly the same way. If you get into longer wavelengths of radio, the propagation is different. For example, in lower shortwave, which is around 300 kilohertz to 3 megahertz, the radio propagation or radio wave can actually curve itself around the horizon, around the curvature of the Earth. It's a ground wave. If we move on to higher shortwave, which is what people in the 40s and 50s used to listen to when they wanted to hear international broadcasts, the properties are different again. The radio propagation is going to do an interesting exercise, bouncing off a top layer of the atmosphere called the ionosphere, bouncing back to the Earth. This is reflection, bouncing up again to the atmosphere, to the ionosphere, and then bouncing back again until it reaches the radio receiver. That's called a skywave, which works in around 3 to 30 megahertz. So what we see here is that radio propagation, like other radio properties, can depend critically on radio wavelength.